8.3 looks at adding and subtracting radicals. So in order to add or subtract radicals, the radicand must be the same. Once you have the radicand the same, you only change the coefficient. This is really similar to adding and subtracting like terms. So let's look at this first example. Our radicands are the same, the number under the radical. So I have 4 radical 5 plus 2 radical 5. That gives me 6 radical 5. Notice that I didn't change the radicand, I just added their coefficient to perform whatever operation between the radicals. 9 radical 3 minus 2 radical 3, my radicands are the same, so I perform that operation. 9 minus 2 gives me 7 radical 3. That is my final answer. It doesn't become radical 6, it doesn't become 0, the radicand stays the same. It would be the same thing as saying 9x minus 2x, you'd be looking at 7x, right? So the number under the radical, the radicand stays the same and you just deal with your coefficient. If the radicands are different, you have to simplify before we add or subtract. If you're sure the radicals are in simplest form and they still don't have the same radicand, that's as good as it gets, and you can't add or subtract them. So that's actually key. This is something you want to highlight and take note of. Once you have them in simplest form, if the radicand is still not the same, you can't do anything with them, you leave them alone. It would be like having x to the 4th plus x to the 7th. They're not like terms, the same variable, but they don't have the same exponent. You can't add or subtract them, that's as good as it gets. So let's look at this first example. It says 2 radical 18 plus 2 radical 32. I don't have the same radicand, so I'm going to simplify these radicals. Turn 18 into 9 and 2, 3 and 3. I circle my final branches. Anything that has a buddy gets to leave. So I have 2 times 3 times the radical 2. These 3's got to leave the radical together. This 2 went back under, and if you remember, I mentioned in the other video, most common mistake, people forget that original coefficient. So it's really 2 times 3 radical 2. So I have 6 radical 2, and then 32 turns into 16 and 2, 4 and 4, 2 and 2, 2 and 2. I circle all my final branches. Anything that has a buddy gets to leave. They get to leave, they get to leave. So I have my original 2 on the outside, this set of 2, this set of 2, and this 2 goes back under the radical. So I have 2 times 2, which is 4, times another 2, which is 8 radical 2. So now I'm looking at 6 radical 2 plus 8 radical 2. Now my radicands are the same, so now I can worry about adding or subtracting them. 6 radical 2 plus 8 radical 2 leaves me with 14 radical 2 as my final answer. If I look at the next example, 5 radical 2 plus 7 radical 3, I can break 2 into 1 and 2 and 3 into 3 and 1, but they're both already prime, so that's as good as it's going to get. I cannot add or subtract these radicals because they don't have the same radicand. So my answer is 5 radical 2 plus 7 radical 3. That would be my final answer. That's as good as it gets. The key thing here is making sure that you're positive it's in simplest form before you decide whether or not it can be added or subtracted. If I look at the next example, negative 6 radical 3 plus 2 radical 3, I do have the same radicand, so I just do negative 6 plus 2 and get negative 4, and I bring the radicand over. I have negative 4 radical 3, and that is my final answer. The next example, 3 radical 8 plus 5 radical 2 minus radical 32. I'm going to try and simplify these because I don't have a common radicand as of right now. Circle my final branches. I remember my original coefficient, so 3 times these 2 partner up and leave, and this 2 goes back under. So this is really 6 radical 2. I have 5 radical 2. That's not going to simplify at all, so I have plus 5 radical 2. Let me pull this down like this. And then my last one, I have 8 and 4, 2 and 2, 4 and 2, 2 and 2. Circle all my final branches. I didn't have an original coefficient, so it's minus. These 2's get to leave together. these 2's get to leave together. And this 1, 2 goes back under by himself. So this is really 4 radical 2. I treat them just like I would treat like terms. 6 radical 2 plus 5 radical 2 gives me 11 radical 2. 11 radical 2 minus 4 radical 2, the whole thing simplifies into 7 radical 2. And that is my final answer. You'll see some that don't simplify into nice radicals where they have the same radicand, and you do just like you did for this example, and you leave them as separate radicals. So let's recap. When you are adding or subtracting radicals, they must have the same radicand. Then you treat them like terms, like terms, excuse me. You leave the radicand the same and you just deal with the coefficient. If they have a different radicand, you try your best to simplify. If they cannot be simplified to the point where they have the same radicand, then you can't combine them.